Hi, this is Lori and welcome to my project on controlling an RGB LED with 3 push buttons using pulse width modulation. Here's the circuit I used for this project. The LED has 4 leads. 3 leads control the red, green, and blue. They're connected to current limiting resistors and then connected to GPIO pins on the Raspberry Pi. The 4th lead, the ground lead, is connected to the ground rail. Moving to the right, the 3 buttons are also connected to the ground rail and then connected to GPIO pins on the Raspberry Pi. Now in this program, how it will work is the LED will start off for all 3 colors. Then as you push a button for one of the colors, it will increase the brightness of that color a certain amount. Press it again, it'll increase it more. And with each subsequent press, you'll increase the brightness until it reaches a duty cycle of 100%. At that point, if you press that same button again, it will make that color go to 0% duty cycle or off. So it kind of is a circular control system for the red, green, and blue in the LED. Now we've learned that LED brightness changes nonlinear with the duty cycle. So a small change in the duty cycle at the low end of the scale appears to be large in our eyes, whereas a large change in the duty cycle at the higher end of duty cycle will be perhaps hard to see. So you can see on this graph, I took a guess at what perceived brightness and duty cycle relationship is. That's the blue line I've drawn, the perceived brightness formula. And you can see here with the red, I've made a small change of 0 to 10%, and that's almost a 40% change in brightness. And then a large change at the upper end from 50 to 100 gives a 7% change in perceived brightness. So that's something important and something we'll have to deal with as we make this program work. So what we want to do is make sure each time we press the button that we get an equal amount of brightness change. So we want to make small changes when the duty cycle is low and larger changes when the duty cycle is high. So this equation, this power equation, seems to work, where duty cycle equals a constant A raised to the power of the number of presses. So what will be important is figuring out the best A to cover the duty cycle range of 0 to 100% within a certain number of button presses. So in my program, I asked the user how many button presses they'd like to have between 0 and 100%. So to find the A, we need to solve for A in the equation, and we do that by recognizing that when the duty cycle is at 100%, we want to be at the maximum number of presses. So if we use that information, you can see that A would then be 100 raised to 1 over the maximum number of presses we want. So I found this all very interesting, and as I was trying to make this program work correctly, I ended up making this table to help me see what the correct A value would be for a certain number of requested presses, and then what the LED level would be for each button press as I went up to 100% duty cycle. So I found this useful table, and it also brought out to me that at some point there's a place where around 16 requested button presses and greater that you start to see little differences at the lower end of the number of button presses. You just don't get much change in the LED brightness level. So there is a point where this equation doesn't maybe work quite as well as one would like. And of course, eventually you just divide up the brightness scale or the duty cycle scale so much that each button press just doesn't make a big difference. So yeah, somewhere around 16 is about the max that maybe you really want to do. So next up I'll show the code for how I implemented this project. So here's the code I used to implement this project. First thing we'll do is import the libraries and set up the pin numbering system, as well as set a small delay time. Next we'll set up the RGB LED, so the red, green, and blue pin, and set those pins up as output. And then we'll need to set up the 3 button pins for the red, green, and blue button, and we'll set those up as inputs with internal pull-up resistors. Next we'll need to create 3 variables to keep track of the button press on the previous loop, so what was the state of the button on the previous loop, and then compare that to the current value to see whether the button has been pressed. We'll also need to keep track of the LED level in each loop, so we know how far we've increased the brightness. Then we'll set up pulse width modulation objects for the red, green, and blue, and we'll use a frequency of 100, but that could be changed. Here I set a variable to contain that, so we only have to change it in one place if we want to change the frequency. Then we'll start with the LEDs off, so just to make sure that they're not lit from a previous run of some other program or a aborted run of this program. And then we'll need to keep track of the number of button presses, and we'll start at 0. Here's where I ask the user to input the number of button presses they wish to go from off to fully on. And then once we know that, we can then calculate the correct constant A in our equation to light the brightness using the nonlinear scale. So once we get into the while true loop, we'll read the 3 buttons to see what the current state is. And then we'll focus in here on just one of the buttons. So here's the red button, and if the button previous was 0, that means it was pressed on the last run of the loop, and now it's 1, meaning that no longer pressed, then that means we've had a button press, and now we want to change the light level. So if the brightness level is getting very close to the 100% duty cycle, we just want to go ahead and set the level to 0. That means it's time to circle back and turn it off and then reset the number of button presses back to 0. If it's not there at greater than or equal to 99, then we'll go ahead and increase the number of button presses by 1. It means we've registered another button press, and then we'll calculate the appropriate brightness level using our equation. And then we'll use the change duty cycle function to bring the LED to the correct brightness level. So we'll do that for the green and blue as well. And then I printed out some information, the number of button presses and the brightness level for the red, green, and blue. So I could see that on the screen. And then now at the bottom of the loop, we'll need to reset the previous to the current, implement a small delay time, and then start the loop again. Once we do a keyboard interrupt to end the program, we'll stop the pulse width modulation objects again, just trying to make sure that the LEDs don't somehow stay on for another run of a program, and then we'll clean up the GPIO settings as well. Here's the actual circuit I used, and I'm just going to zoom in a little bit here and show you the connections for the RGB LED. You can see the resistors and the wires going to the Raspberry Pi. And then you can come over here and see the 3 buttons I have set up for red, green, and blue, also connected to the Raspberry Pi and the ground rail. So let's see this thing in action. Come up here and we'll kick this program off. And come down, you can see here's where the user is being asked to input the number of button presses they want. So I'm going to choose 5. And you can see the printout So that's the number of presses and the LED level for red, green, and blue. So let's come down here and press the button. And I'm going to put a little black piece of paper here, just trying to see if we can make that show up just a little bit better on the screen. And let's try the red. On here, and we'll turn it on, and you can see the reds come on. And I'll just show that now you can see there's been one button press, and the LED level is 3 for red. All right, so that was 1, and we asked for 5. So let's so that's 1 press. So let's go 2, 3, 4, 5. So let's see if we're up to 100% like we asked. And yep, we are. So if I press it one more time, you'll see it goes to 0 and it's off. So that's how it works for all of the buttons. I'll just quickly show that that works. And blue. And then, you know, you can now mix things, right? So you could press 2 at the same time. And you can see here, I'll just show, you know, I've been pressing the green and blue, and we're at an LED level of 6. And I'll just show you continuing it to increase. That's fully on. And I press it one more time. Oops, just the fully off. So that's how it works. I enjoyed this project, and I hope you enjoyed seeing how I got it done. Thanks, everyone.